Hello, Physics 1 students. Mr. Durango here with your next assignment. We're in the chapter on DC circuits, and we're going to start to get into the meat of this chapter now where we analyze circuits. And so let's get right to that. The first kind of circuit we're going to analyze is the series circuit. And so you can turn to that page in your slide. So a series circuit basically just means that we have a circuit that has a singular path that the current must flow through. There's no choices that the current has to take any other path. It must follow one path from the positive terminal of the battery to the negative terminal of the battery. And so those kinds of circuits have the following characteristics. They're the total resistance that the battery sees can be obtained easily by just adding up the resistor values, and we'll call that R equivalent. The current that flows in a series circuit would then just be the battery voltage divided by that equivalent resistance. And in series circuits, all of the components must be working for the circuit to work. Let's get right to an example so that you can see what I'm talking about here and all these characteristics. In this first example, we have a battery that is hooked up to five resistors, and they're all 2 ohms. Whoops. 2 ohms and 2 ohms, and the battery is 24 volts. And we have to find several things. The equivalent resistance. Well, we know the equivalent resistance is just the sum of those resistor values. So R equivalent is going to be equal to 2 plus 2 plus 2 plus 2 plus 2, which is equal to 10 ohms. And for part B, the current in each resistor. So current's going to flow out of the battery like this, and it's going to flow like this. And since only energy is being dissipated as it goes through the resistance, the current is all the same. The current flowing through each of these resistors will be the same. And so we can find that current by taking the battery voltage and dividing by the equivalent resistance. And that is 24 divided by 10. And so the current that flows through each resistor is 2.4 amps. The potential difference across each resistor, well, if we can use, again, V equals IR, we can use this equation over and over again, since we know the current that flows through each of these resistors, it's 2.4 amps, so we know each resistor is 2 ohms, then we know that the voltage that drops across each resistor will just be 2.4 times 2, or 4.8 volts. And you'll see that if you add 4.8 and 4.8 and 4.8 and 4.8 and 4.8, you'll get 24 volts, which has to happen because of the conservation of energy. So I'll give you a problem to try and send you an email with the assignment. And if there are any issues, please get in touch with me. Until next time, take care and stay safe. Bye-bye.